Welcome back, everybody. Now it's time to talk about dictionaries. Dictionaries are unordered mappings for storing objects. Previously, we saw how to store objects in an ordered sequence using a list. But now, dictionaries will allow us to store objects using what's known as a key-value pairing instead. And this key-value pair allows users to quickly grab objects without needing to know an exact index location. Instead, you just call the key and it returns the value associated with that key. And the dictionary syntax uses curly braces and colons to signify the relationships between a key and their associated values. So here we can see the curly braces, and then we have the string key, so key 1, then colon, and then whatever value is associated with that. In this case, we just have a string called value 1, and then we have a comma for the next key value pair. Now the question always arises, when do we choose a list, and when do we choose a dictionary? Well, dictionaries have objects retrieved by a key name, and dictionaries are unordered and cannot be sorted. So a good time to use a dictionary would be when you want to quickly retrieve a value without needing to know its exact index location. Now that's a really nice feature of a dictionary, the fact that you don't need to know where something is in the actual dictionary to call it, you just need to know the key value pair. However, that comes with the con of not being able to sort a dictionary. Because a dictionary has a key value mapping, it means that it's going to insert new key value pairs wherever it deems most efficiently. Lists, on the other hand, can retrieve objects based off locations. So that allows the actual list to be indexed, sliced, and then sorted. So you kind of lose that functionality when using a dictionary, so you're basically trading off ease of calling and grabbing something from a dictionary very quickly with a key value pair, and you're losing the ability to sort things or have an index location off of them. Okay, let's explore these concepts a little closer by jumping to a Jupyter notebook. Let's begin by showing you how you can construct a dictionary. We'll start by saying, or create an object, my dictionary, and then we'll have curly braces, and we'll define a key. So keys should be string, and you can call them whatever we want. So we have key 1, and then we have some associated value with that key. For now, we'll stick with basic strings. Then we have a comma, and you can insert a new key value pair. So colon, and then another value for that. Okay, so we have our dictionary here. And then if we call it back, we'll end up getting the entire dictionary. But really what we want to do is grab values from this dictionary. So instead of using index locations, we still use the same square brackets, but now to get a value back, we just pass in the key that's associated with that value. So we can say in my dictionary, pass in key 1, and we get back that value itself. So a good example of a use case for a dictionary may be something like prices in a store. So we can say I have a dictionary called prices, and we can even call it price lookup. So we have this prices lookup dictionary, and we can have different items in the dictionary, such as apple, and then their associated price. So we'll say apples are, I don't know, $2.99, maybe per pound, whatever. These are made up prices. We can have oranges. Those can be $1.99, and then we can have, let's say chocolate. Well, let's say milk because it's a little shorter type. We'll say milk, and that's going to have a price of $5.80, and there we go. So then, with my dictionary, and remember this dictionary could be huge, prices lookup, I would just want to know, hey, what's the price of an apple? I'd pass an apple, run it, and it returns back the actual price. And now, without needing to know any sort of index location, I can easily get the prices of any of these objects using the key value pairs. So that's a really good example of why you would need a dictionary instead of something like a list, because here I have two values that I want to associate with each other and quickly look up the value of one given its key. Now it's important to note that dictionaries are actually super flexible in the data types they can hold. I just showed you how they can hold integers or floating point numbers as well as strings, but they can actually hold lists or even other dictionaries. So I'll just show you this as an example. We'll say D is equal to, we could have K1 be equal to a key, and it could have a number associated with 1, 2, 3. Or the other thing I could do is say K2, and I can actually have a list associated with it. So I can say 0, 1, 2, and then I can even do another dictionary inside of this dictionary. This is not that common, but it is supported. So we can say inside key, and then have some other number here, 100. So the dictionary itself has no problem dealing with all of this. And if we ever want to grab elements from this, let's imagine I wanted to grab this list, 0, 1, 2. Then I just call D, pass in its key, K2 in this case, whoops, it should be a string. Run this and I get back the list. And then if I wanted to grab this number 100, what I could do is say D, find the associated key for that, K3. And when I run that back, I get back this dictionary. So off of this, I can make another key call. So then I could just say inside key, copy that, run that, and then I get back 100. So notice what's happening here. I'm basically stacking either index calls or key calls to get back the values I want. So let's imagine that I wanted to grab the number 2 here. What I would need to do is say D, K2, which returns back a list, and then I want the item at index 2. So then I could just say 2, and then I grab back 2. And this whole thing can be a little confusing at first, so let me walk through one more example just to make sure this is clear. I will say my dictionary has a key 1, and associated with this key is a list of lowercase letters, A, B, C. I run that, I check my dictionary, key 1, A, B, C, and let's go ahead and try to grab the letter C and make it uppercase, because it's a string. What I could do is, through various steps, do the following. I could say my list is equal to D at key 1, and then if I check my list, I have that, so then I could say letter is equal to my list at index location 2, and then if I check out my letter, I then just say letter, uppercase, and then I have capital C. So notice all the steps here that I did. I first grabbed the key, then I made that into a list, then I did the indexing off that list to grab the letter, and then I said uppercase off that letter. But I can actually do this all in one step because of how flexible Python is. I could say, okay, grab that key, which returns back the list. So then off of this, instead of reassigning it, I can just keep calling what I want. So then I want to index by 2. There I have the letter C, and now that this is a string, I can call dot upper, and there I have uppercase C. So you could do it this way as well, instead of having to do each of these steps. Now you're not going to be doing something like this so often, but you do sometimes leverage the power of dictionaries to be able to hold lists inside of them. Okay, so I just want you to be aware of that you can kind of stack calls like that on a singular object. If we ever want to add new key value pairs to a dictionary, it's pretty straightforward. So let's make a new dictionary here. We're going to say K1 is 100, and we'll say K2 is 200. So here I have my dictionary, K1 and K2. Let's imagine that I wanted to add K3 is 300. All I need to do in that case is say D, assign a new key, so K3, and set that equal to 300. And then when I take a look at the dictionary, I now have K3 300. All right, so we just saw how we could add a new key value pair to the dictionary. We can also use the same method to easily overwrite an existing key value pair. We can say D of K1 and set that equal to some new value. So to make it really obvious, we'll just have a new string there, new value, and then if we call D, we see K1 now has that new value associated with it. Finally, I want to discuss just a few useful dictionary methods, and those are methods to grab all the keys, values, or items off a dictionary. So we have our dictionary right now, K1, K2, K3, new value 200, 300. I'm going to reassign it to be the old one. So let me copy this right here and say D is equal to that version of the dictionary. If I want to see all the keys of a dictionary, I can say D.keys, and that's going to return back all the actual keys. If I want the opposite and I want all the values, all I need to do is say D.values, and that returns back the values. And then if I want the actual pairings together, I can say D.items, open and close parentheses, run those together, and it returns back the pairing. So K1 goes with 100, K2 goes with 200, K3 goes with 300. And these, you'll notice, are actually in parentheses, and that means this is actually a tuple, which we're going to learn about very soon. Okay, that's really the basics of dictionaries. Let's do a very quick overview of what we just learned. Dictionaries, their main syntax is defined by curly braces. You have a string key, colon, and then a value. And Python's really flexible as far as what this value can be. It can be another string, another list, another dictionary, floating point numbers, integers, etc. And then you can have another key value pair, and you just separate these by commas. The keys themselves should always be strings. And then we can easily look things up by just a key lookup. Again, it uses that same bracket notation we saw earlier with indexing, except now instead of passing in an index position, you pass in the key itself. We also saw how we can call nested objects inside a dictionary by just basically piling on these key and method calls. Then after that, we saw how we could call the keys, the values, and the items off a dictionary. All right, that's the basics of dictionaries. We'll dive into more detailed aspects of dictionaries later on. We'll see you at the next lecture.